warm up here.
Sure.
And we will probably have some staffers coming too.
Okay, great.
Good afternoon. I'm Senator Andrea D'Alessandro, and I'm the ranking member of Natural Resources, Energy, and Water on the Senate Committee. And I'd like to welcome everyone here. This first session came about because during this session, all of the bills concerning the environment come to our Natural Resources, Energy, and Water Committee, and things get so hectic, and we wanted to bring in some experts from around the state to address us on issues that are related to the environment and concern our state, because I feel our state in many ways is very vulnerable. And so our first panel is composed of people from the University of Arizona who've kindly traveled from Tucson to be with us today. And I will ask them to introduce themselves and choose the order that they're going to go into. And we're very grateful that this is being taped, so other members who couldn't attend today will be here. We'll be able to watch it in the future, and I will be sharing the link with our entire legislature and our research staff. So welcome to the Arizona Senate, and please introduce yourself and decide which order you're going to go. I should have asked that before.
Sure. Would you like to introduce ourselves separately?
Yeah, that's it. Good.
So thank you, Senator D'Alessandro, for the kind invitation. It's a real honor and a pleasure to be here this afternoon. My name is Greg Garfin. I'm a climate scientist at the University of Arizona. I'm an associate professor and also associate extension specialist in the School of Natural Resources and the Environment.
Hi, I'm Elise Gornish. I'm a cooperative extension specialist in ecological restoration at the University of Arizona.
Afternoon, I'm Don Falk. I'm a professor in the School of Natural Resources at the University of Arizona. I'm a forest ecologist, and I work statewide and throughout the western U.S.
Good. So as I mentioned, it's a pleasure to be here, and we will be speaking about climate, fire, and forests in Arizona and the Southwest. As a climate guy, I frequently talk about things that are on timescales of decades to a century or more, but I do work as well on shorter timescales of extreme flood events and droughts, things that can extend from weeks to months to years and even a decade or more. The kind of science that we're presenting this afternoon is also science that's used by or consulted by organizations such as Salt River Project, the U.S. Bureau of Reclamation, and many others. And the thing that I'd really like to emphasize is the way that we work. We work in partnership with decision makers around the state and throughout the southwestern U.S. Those decision makers, natural resource managers, they can be individuals, non-governmental organizations, Native American tribes, state and federal natural resource managers. And the key is that we work in partnership with them in order to make sure that the results of the science can be not just useful, but usable in their work to inform their decisions. So I would like to give you a brief overview of where we're going this afternoon. We're planning on doing a sort of a tag team here between the three of us. We'll try not to take too much time because we'd like to get to have a discussion with all of you at the end. I'll speak very briefly about climate and weather concerns with the state, talk about historic climate variations, and then I will hand it to Don, who'll speak about forests and fire. And then Don will hand it to Elise, who will speak about vegetation management after fires. I'll come back and talk a little bit in more detail about how we work, and then the three of us will give some examples of the kinds of solutions that entities in Arizona are currently using, and some ideas that we have for research that can be applied to resource management decisions. And then, as I mentioned, we'd like to hear your questions, and we'd also, if you're willing, like to be able to ask you some questions. I was going to say one other thing, and I forget what it was, so I'll just move on. Great. So when it comes to concerns about weather and climate in Arizona, in the years that I've been working on this, since at least 2000, it generally boils down to four categories. Either we have too much water, or it's too dry, or it's too darn hot, or the combination of hot and dry lead to ill effects like wildland fires. So how do we get in those sorts of situations? This graph shows Arizona annual precipitation, the average total across the entire state. The individual, it's measured in inches, and the scale at the bottom goes from 1895 to 2017. The individual bars are individual years precipitation. The orange wavy line is the 10-year average. And then the line going horizontally across there is the annual average precipitation for the state, measured from 1981 to 2010, which is the 30-year reference period used by the National Weather Service. So what do we see in this graph? Well, something that we're all really familiar with. There's a lot of year-to-year variation in precipitation. We have some very high years, some very low years, and it varies a lot from year to year because of interactions, primarily between the ocean and the atmosphere, with the Pacific Ocean having a huge influence on our climate. Old friends like El Nino accounting for some of those very high precipitation years, and La Nina, its opposite, accounting for many of the low precipitation years. One of the things we can see with the wavy orange line is that we get into periods that are, by and large, we have above average precipitation. Then we go through drier periods, like in the 1950s and 60s. And then most recently, a dry period that initiated in the late 1990s. Notice that there's no overall trend, upward or downward, with the historic record of precipitation in Arizona. This is a similar graph of temperature. Again, the horizontal line is the 1981 to 2010 average, and the red bars are above that average, the blue bars are below that average, and the black wavy line is the 10-year average. So again, we have a lot of year-to-year variability, and we have a little bit of multi-decade variability that you can make out in the wavy line. But the difference between the temperature record and the precipitation record is that there's been an upward trend in temperature that's been particularly strong since about the 1970s. This kind of variation in precipitation and temperature, it's not just occurring in Arizona, but across the Southwest, again, where we have decades that are wetter than average, decades that are drier than average, lots of variability. And again, with temperature, the key factor here is the upward trend in temperatures across the southwestern U.S. And in the absence of a similar upward trend in precipitation, this trend in temperature has effects on hydrology in our region. One of the key ways it affects hydrology is through snow. And what we've observed in the southwestern United States is earlier snowmelt runoff, also less snowpack, a longer snow-free season, and an increasing fraction of late winter and early spring precipitation that falls as rain rather than snow at elevations roughly lower than about 7,500 feet. We've also seen a statistically significant decrease in soil moisture across the southwestern region, again, driven by the increase in temperature, which increases evaporation and also decreases the recharge of soil moisture. And these sorts of things are part of the factors that have exacerbated drought in our region. So we're having hotter drought in the region. The influence of temperature also affects, and this sort of hot drought also affects vegetation such as our conifer forests. This particular photo is from New Mexico. Northern New Mexico could just as easily have been from northern Arizona. All of the trees in the photo are conifer trees, so they should all be green, but you can see many of them have just died and they're retaining those red needles. The increase in temperature adds drought stress to these trees. It also enhances the life cycle of the critter pictured in the lower right, bark beetles, pine bark beetles, and the combination of those two has led to a substantial death of conifer trees throughout the southwestern United States. In addition, having a longer snow-free season and higher temperatures gives us a longer fire season with drier fuels and also a tendency for these fires to be larger and more severe, in part due to those increasing temperatures. Sometimes the fires can be stunningly severe, as from this photo from the Chiricahua Mountains in southeastern Arizona, where this is what we would call a stand replacing fire, and certainly with a lot of damage to the soils. Another factor that's affected by the observed increase in temperature is summer precipitation. Some research that was released this summer by Chris Castro at the University of Arizona shows that as the atmosphere warms up, it can hold more moisture. And what Dr. Castro's research shows is that the intensity of summer precipitation has increased throughout the historic record of precipitation in southern Arizona. Of course, those kinds of storms can lead, following fires, to large debris flows like the ones pictured here after the 2011 Schultz fire just outside of Flagstaff, Arizona. And those kinds of post-fire effects are critical, and Don will speak more about the effects on forests and fires.
Thank you, Greg. So I want to zoom in a little bit more on the fire question. It's a very complex issue, but I want to begin by just reminding ourselves what's at stake. We don't think of ourselves as a forest state, depending where you live, but in fact we have 10 million acres of forest in the state. It's 14% of our land area, and various estimates of the economic value of those forests are some very, very large numbers for tourism, recreation, and so forth. And when I served on the governor's Forest Health Council a few years back, we did an assessment of the economic contributions of forests. So even though I'm an ecologist and most of my concerns tend to be within the natural resource sphere strictly defined, I do want to point out that there's some very big economic values at stake here. There is also almost all of our water at stake in the condition of our forests. Essentially, all of our water supplies originate in high mountains, not only in Arizona, but in adjoining states in the upper and lower Colorado River Basin and other watersheds. So the snowpack dynamic that Greg mentioned is not simply a matter of what the ecology is like up in high mountains, but it is ultimately the source of all of our water, both in short term and long term. So this means that both our economy and our water are deeply tied to the fate and condition of our forests, two things that arguably would be of great concern to anybody representing the people of Arizona. Forest fire, as we see it today, is a very different manifestation from what it looked like historically. We know from the tree ring record, as you can see from the inset there, a dated piece of a Douglas fir that has been dated using tree ring analysis and the years of individual fires worked out. And you notice that one slab, which is not unusual, has about 20 fire dates on it. That means that the fires were not killing the tree. They were hot enough to scorch it, to kill a bit of the growing surface, the cambium. But these are not tree-killing fires. We can look back in the record more than 500 years, and in some areas longer. And what we find is the presence of fire in our forests, but not the kind of devastating tree-killing, stand-killing fires that Greg showed a moment ago, but much more like what's in the background, the main image of this paper, which is this photo, which is a surface fire, burning grasses, litter, duff, small branches, maybe shrubs, but not killing the overstory trees. This makes a huge difference because in the absence of those fires, then all of those fuels start to accumulate, and I'm sure you've heard this story many times before. That has changed the fuels in Arizona forest, and that change in fuels is giving us the fires we are seeing today. So we really have a type change in the kind of fires that we're seeing today from the historic fire regime of low severity surface fires, which is what our forests have evolved with, to the kind of devastating fires we see today. And instead, so this is now the kind of typical manifestation. Classically, this is the 2004 Nuttall Gibson fire burning in the Peñaleno Mountains within sight of the most expensive astronomical installation in the state. And again, it's not to say that big fires didn't occur historically. In fact, we can use tree ring analysis to map out how big fires were historically, and in some mountain ranges where we have enough data, we can see these creeping ground fires burning all summer and maybe even overwintering into the next year, but not with this kind of extremely destructive behavior. So the consequences of these kinds of fires are now becoming all too familiar to us. Instead of simply burning grasses and pine needles and a few branches, they're consuming everything in their wake. And you can see from this picture steep slopes. There's not a living tree in sight. In fact, this is in the middle of a very large, probably 10 to 15,000 acre high severity patch with not a single tree left alive. It's not hard to see also that the watershed values here have been severely compromised. There's going to be a tremendous amount of erosion. The water is going to be silted. Fish populations will die. This is a truly devastated landscape. As it happens, so now then we have to ask how much of the land area is being affected by high severity fire of that kind. So if you look along the time axis on the bottom, you'll see up until about 2000, most fires, these are the largest Arizona wildfires by year. And you can see that the largest fires were in that 20 to 50,000 acre range. When I moved to Arizona in the early 1990s, the Rattlesnake Fire happened within a couple of years after that, and that was a 22,000 acre fire, and I had never heard of such a thing. I thought that was just devastating and catastrophic. And you can see then what happens when we get into the 2000s in the drought episode that Greg mentioned. Fires are now an order of magnitude larger, 10 times the size, from 20 to 50,000 acres to 200 to 500,000 acre fires. That, to our knowledge, is unprecedented. And if you look at the names of those fires, the big ones, you recognize those as the big, highly destructive fires. So the bottom line here is that wildfire is beginning to have a cumulative impact on Arizona forests and all the values that come with it. Looking forward, what we're concerned about is that, especially again on the temperature signal, which Greg has mentioned, with a kind of business as usual projection on the upper panels and a more optimistic scenario on the bottom. In either case, temperature is going out of the envelope of historical variability. And in fire, we look a lot not just at pure temperature, but red flag days, which include combinations of temperature, humidity, and wind. And I don't have a record of red flag days to show you today, but I can tell you the number of red flag days has been increasing, and that means that the fire season is getting longer and more severe. Looking farther out in time, we've done some work to try to estimate how much area is going to be burned, not only in Arizona, but throughout the West. And we look at area because area is a multiplier of fire effects. If you have small areas burned, everything is concentrated. If you have large areas burned, you have a lot more work to do over the entire region. And you can see by the redder, the warmer colors here, which are greater increases in area burned, that almost the entire interior West is projected to have big increases in area burned. What this means is that a lot of the values that I showed in the very first slide are increasingly at risk if we don't get a handle on the fire problem. Lastly, I'll just come back to the point about flooding that Greg made. This was part of a project we did with the Department of Defense, looked at fire and flood risk on several military installations throughout the Southwest. Here at Fort Huachuca, during our project, or I guess just before the beginning of our project, we had the Monument Fire 2011. And that was a high severity fire that burned initially on public lands. As you know, it burned out into a lot of private, state and private land as well. But the big risk was from the post-fire flooding. We saw this in Colorado Springs, where even though a major fire in 2012, the Waldo Canyon fire, was all on public land, the big economic losses and all of the fatalities were from the post-fire flooding, debris flows and high flows like this. So I want to link our thinking about fire and not think of it as simply happening on public lands and not simply affecting forests, but the downstream effects, which can be very severe. So we know that many southwestern ecosystems are resilient. They can handle periods of fire and climate variation, but it's clear that we need to think about these problems in some new ways. And so I'm going to hand off to Elise to talk to us about what some of our responses are.
Thanks, Don. So we didn't want to just come here and give you doom and gloom. There's certainly a range of strategies and technologies that we can utilize in order to mitigate the effects of fire and also provide resilience to our landscapes for the next inevitable fire. So generally, these approaches can fall and address these three goals. So reduce the incidence of invasive species, which can really come in very quickly after a fire and take advantage of that large disturbance. Reestablish native plant communities. That's both the understory of the forest as well as our native trees. And then again, provide resilience to sort of provide more healthy ecosystems so that when fires do burn through, they have a smaller effect. So generally, to address these first two goals, we use something called ecological restoration, which has lots of different definitions, but the Society of Ecological Restoration defines it as the process of assisting the recovery of an ecosystem that's been degraded, damaged, or destroyed. So essentially, these are approaches that leverage the natural succession or the natural processes that would occur after one of these large damaging events on the landscape. And when I'm talking about ecological restoration, this can be kind of what you think about when you're planting tree seedlings to reestablish the overstory, or seeding, either from fixed wing airplane or even through hand seeding of the understory, which is also a really important part of forest ecosystems. There are lots of direct benefits of restoration. Again, you can get that enhanced biodiversity of your plant systems, which also provide restored wildlife ecosystems, and erosion control. So all those plants that burn out, their root systems start to die, and it's really those root systems that secure and resist the movement of sedimentation. So when you get plants back out, you have a minimizing of soil movement. And then there's lots of indirect benefits. So you get invasion resilience. When you have plants out there, it's much harder for invasive plants to come in. You have reestablishment of soil nutrient dynamics, which are really important for water. There's a lot of enhanced local community business opportunities. So you've got to hire people to put these plants out there. You've got to buy the plants, hopefully from local sources. And then restoration can act as a fire break. So if you've got plants out on the landscape that are greener and healthier longer into the fire season, there's going to be more moisture in those plants. And so it's going to act as a natural fire break to reduce the intensity of a fire. So this is a photo from, I forget the name of the fire, but it's from a fire in Utah. And over on the right, this is an area, a large area that was seeded in 2002. And when a fire went through during a drought period, there was essentially a fire line right at the edge of that restored area. Okay, so you're also providing resilience. Of course, there are challenges associated with any management strategy. Restoration can be extremely costly, both for the restoration materials as well as labor. They're resource and data hungry in the sense of you have to know a lot about your system, what was there before and what sorts of dynamics were going on in order to recreate that system. It can be difficult to acquire appropriate materials when you've got hundreds of thousands of acres burned. Not all native nurseries have enough seed to cover that. So grass seed, usually you want to use about 20 to 30 pounds per acre. So if you're thinking about that per acre and you have 500,000 acres burned, there aren't that many sources to get that much seed. And of course, success can be driven almost entirely on weather. Anyone who has a garden knows that you can do everything you can to plant something. If you don't provide it water, if it doesn't rain, you can get total failure. In addition to addressing disturbance right after a fire, we also have a bunch of approaches that provide utility for providing resilience to the next fire. The most commonly used one is thinning. And so thinning in forests essentially is the removal of smaller trees. Usually these are 10 to 20-year-old trees. These are trees that have more foliage closer to the ground. So what you're doing is you're removing some of the fuel load as well as providing more resources in terms of soil moisture and sunlight to the trees that remain, and they become healthier. So you have the direct benefits, obviously, of a reduced fuel load, healthier trees, and a more diverse understory because you're enhancing the heterogeneity of the understory, so you have a nicer complement of forbs and grasses. There's a lot of indirect benefits. A lot of them are economic. So those trees that are removed can be used in the timber marketplace. There's some work that shows that thinned forests are more resistant and resilient to bark beetle and pest outbreaks. And again, you have enhanced local community business opportunities because you've got to pay people to come in and take out the trees, move the trees, process the trees. Of course, there's challenges associated with thinning. So if you take trees out, you got to move them somewhere, and there's got to be a place for them to be processed. You have carbon loss because you're actually removing plants. These are live, ostensibly not dead, healthy trees. You're removing them from the system. Anytime you remove plants from the soil, you have a chance of soil erosion and wind damage. Soil erosion and then wind damage can occur when you have just less trees and there's a lot of wind. You can get healthy trees knocked down. And finally, you're deploying some kind of disturbance on the landscape. So the elephant in the room of all this, of course, is how much does it cost? We can come up with the ideal, perfect management situation after a fire, but if it costs too much or if it doesn't pencil out, we can't use it, right? So how much does this cost? Well, on average, it's about $400 an acre. So $300 an acre for really minimal thinning, up to $500 an acre for thinning and restoration. So what does that compare for what we're seeing on the ground? Well, our second largest fire cost about $277 an acre. This is just for restoration, okay? But what the fire cost us was almost $388 per acre. That includes putting the fire out, emergency funds, paying for houses and damage loss. So what we would be paying for restoration and management after a fire can be a small fraction of the total fire cost, and actually bring down the fire cost if we provide resilience. To compare this to other states and other fires, those words are really small, so don't worry about the words, but what I'm showing you here is 3 pie charts showing the costs associated with a fire. This is everything from suppression all the way to emergency funds and restoration. Rehabilitation is the cream-colored slice. So on the left, there's a fire from Montana, and rehabilitation cost about consisted about half the cost of the total fire. But if you look at the other 2 fires, one is from Colorado and one's from Utah, rehabilitation was a really small slice. So we're talking about scientifically proven, for the most part, field-tested approaches that can really pencil out for us.
Thanks, Elise. So I'd like to return to this topic of how we work and then head towards our examples and discussion. So we work, especially Elise and I as extension specialists, work at this boundary between practitioners and scientists. Practitioners being people out there in the real world who make decisions, and scientists tending to be researchers. So we try to span this boundary, and we do it by working closely to build relationships with practitioners. So in this somewhat complicated looking diagram, it basically describes how we work over time to develop trust relationships in a collaborative way, that we can narrow that gap in communication. Scientists talk in their jargon, people out there working, as Paul does with the Department of Water Resources or other departments, they have their own jargon and their own culture. And it's a getting to know you kind of exercise. You have to learn the different culture. What are the opportunities and what are the constraints? What are the constraints on the science side? What are the constraints on the agency or decision maker side, and so on. But we found that we can make the science more useful and usable and be more successful in the application of our science if we work in this collaborative mode. And in doing that, what we're aiming for is a good partnership, a strong partnership that will endure like a good marriage will. And in doing this, often because we're scientists and we're working often with novel or experimental kinds of approaches, we aim to identify the early adopters, people who either by their temperament or the nature of their business can afford to take risks, and who sum up the science and think that that the payoff will be, the return on investment will be worth the risk. Again, we work to develop trust relationships in order to be successful. And we don't have to develop those trust relationships as individual scientists, though we often do. But we can work with other organizations that are at this kind of boundary, such as trade associations, maybe like the Arizona Hydrological Society. We might work with county extension agents who have strong trust relationships with citizens in their counties. We may work with public health officials who would have a close association with end users, or an organization like the Society of American Foresters, and so on. But the key thing is to establish a collaborative link and develop that trust relationship to work together to define the science question, frame the question in a fruitful way, and also to agree upon the methods that would be acceptable and the way that we would convey the results so that they can be usable to inform decisions. And we also work with our students in this way, building upon their solid science foundation. We also try to impart to them skills on understanding the decision context, how to communicate their science, how to facilitate meetings successfully, and how to work in teams in a way that can lead to good outcomes. So there are many things that we can do together, and there are many things that Arizona organizations and agencies and communities are already doing. And one of our goals is to discuss with you ways that we can work with your constituents and communities and with you to work together. So we'll just give some very brief examples of some science society partnerships. And these are a smattering of hundreds of projects that either some of us have worked on or some of our colleagues have worked on. For example, we worked with Tucson Water to develop a conversation that seeded the drought plan that they developed. We've worked with the Salt River Project, doing the kind of paleo science, reconstructing past stream flow and drought for the Salt and Verde River watersheds, and they've used that information to inform the way that they manage the large reservoirs on those rivers. Our colleague, Dr. Sharon Megdal, the director of the university's Water Resources Research Center, works with many water management decision makers in the state. Recently, she applied similar climate and hydrology research to working with the folks on the Santa Cruz active management area. I've done work with cities like Tucson, Phoenix, and Flagstaff on extreme climate and weather episodes and preparing for those. Some of our colleagues have worked with ranchers in the Tonto National Forest in the Avra Valley west of Tucson, and with the Sonoyta Valley Planning Partnership in informing the management of the Las Ciénegas National Conservation Area and coming up with some scenarios of the future and developing ways that they can better monitor and manage the landscape to anticipate those futures. And then, as Don mentioned, we've done work with Fort Huachuca and other military installations on fire and vegetation management. And I'm going to hand it to Don to describe some other techniques.
So I'm just going to mention one of many techniques that are a way that we can work together across jurisdictional boundaries to reduce the fire risk. And the goal here is to avoid the uncharacteristic high intensity fire behavior. You have to get a grip on fire behavior, and then in so doing, you create better fire effects. There's this strong link between behavior and effects in the fire world, and the effects are mostly driven by the behavior that happens during the period of live combustion. So ultimately what we're trying to do to accomplish is to avoid these catastrophic high severity effects and all the watershed effects that go along with those. These can actually very readily be accomplished by reducing surface fuels, this accumulation of fuels that I mentioned earlier, by a variety of thinning methods, especially prescribed fire and mechanical thinning. These can be done proactively in an area, pretty much any area that's identified as having an excess fuel loading. Fuel treatments don't last forever. You have a shelf life of maybe 10 to 20 years, so it's not once you're done forever. You'd have to go back into an area that's been thinned and burned and do it again, or at least get into a cycle of lower, much easier prescribed burning after the initial thinning. The main thing you're trying to do here is to reduce the volume or the mass of surface fuels, the ladder fuels, which Elise mentioned, which carry fire from the surface up into the tree canopy, and then reducing the canopy fuel density by increasing the spacing of trees, and especially retaining large trees. This is why the traditional commercial timber logging approaches do not accomplish the objectives of thinning, because of course that approach is after the large trees, and the large trees here what you want to retain. So you need to use a different method, but these methods have been shown to be very effective, and not just under prescribed fire conditions, but under extreme conditions of wildfire. I just want to give you this one example. This is the footprint of the 2002 Rodeo Chetasky fire, and this is after the two fires had merged. And the color indicates the fire severity, that is the effects on soil and overstory trees. The red orange areas are where most of the overstory trees have been killed and the soils were severely damaged. And then you'll see these green polygons dotted throughout the fire, and some of them are actually quite large. The lines around those green areas are previous treatments, prescribed burning and thinning, in the 10 to 15 years prior to the fire. And so the take-home message from this image is that even under extreme conditions of what at the time was the worst and largest wildfire in Arizona history, these treatments actually work under those extreme conditions. And as you can imagine, tremendous saving of a firefighter risk, the risk of citizens, and the cost of fighting the fire, and then the cost of rehabilitating everywhere. So the bottom line is clearly getting out there ahead of the curve, not waiting until we have an extreme event on our hands, can save us a lot of money and a lot of ecosystem damage.
So another example of an approach which actually couples sort of addressing fire after the fact as well as providing resilience is the use of green strip restoration. So green strip restoration is essentially restoring small strips of land within a larger matrix. And what you hope for is that you install mostly plugs, sometimes you can seed, but these plants are greener for longer in the fire season, so they have a higher moisture content. So essentially they act as these rumple strips or buffers that would slow down a fire and reduce its overall intensity. So you are both restoring an area by getting desired species down on the ground, as well as providing resilience for the next fire. There are some examples of where this has been used in California. This has proven to be really, really useful in the Great Basin in these huge areas that are dominated by cheatgrass and experience major wildfires all the time. So this is certainly an approach that would provide us utility in Arizona.
Thanks. So I'd just like to close by saying that what we're aiming for is win-win solutions, solutions that are good for our natural resources and environment in the short term, and of course good for our economy, and also that makes sense anticipating future changes as well. And as I mentioned earlier, always in partnership and always with the health and resilience of our natural resources in mind. And with that, we'd be happy to take your questions, and after your questions, if you're willing, we'd like to ask you some questions. Yes.
Hi, I'm Senator Lisa Tondo. So when I met you initially at the beginning, and I worked with you on this, the Best Land Management Practices bill that I ran 4 years ago, we had initially asked for $10 million. We weren't going to get it through. And it ended up dwindling down to nothing. It was run by a striker, by a shooter, just to get it through. A lot of the numbers that you had, $400 to $500 per acre, for cleaning up some of our state than being proactive and doing it initially. The costs are much higher at the end game. So what do you suggest? I've suggested public-private, tried to go that route. Sometimes public-private doesn't work out. I just met with the Commissioner of State Lands, and she said, at least we're gonna be trying something new this time. I'm really looking forward to it. I'll let you know as soon as we get it on paper. What do you see happening? I mean, other examples of cooperation are Forefry. Forefry's done some great things, but what can we do to actually get our state lands in order?
Well, I can start. I can start off. Yeah. So you used the word investment, and I think it's a good word because when you invest, you are putting money out to begin with because of some benefits that you're going to derive later. The fact is, with fire, you're going to pay sooner or later. If you wait until you're cleaning up a big mess like Rodeo Chetasky or any of the other big fires, you're going to pay way more, not only per acre, but in economic losses, employment losses, healthcare demands on the healthcare system, fatalities of citizens, fatalities of firefighters. And so even though you're investing now to prevent that, you could say, well, the costs of the severe event are somewhere in the future, but it's exactly like investing in a healthcare system. You don't wait and treat everybody in the emergency room. Well, some people would argue that, but we don't think that's, you wouldn't construct a healthcare system that way. And so in terms of making the case, yes, it's preemptive. You're trying to get things in order so that you don't have those catastrophic events, which you're going to pay for later, and you're going to pay many times over what it costs to do it up front.
Excuse me, Senator Tondo, if you'd be so kind, if you have a follow-up, to come to the podium that they could film you. Thank you.
Thank you. And that's exactly my point, is a lot of us are fighting to make this very smart investment, a proactive action, if you will, because the costs at the end are much greater. But in the state of Arizona, our finances and everything else, I guess what I was asking you is, do you believe a public-private approach is best? What, in terms of policy, because it's very difficult to get money to support this, or if it is money, should it be money to the state land department? What do you feel would be the best approach financially or policy-wise to actually really do some of the things that we're talking about? Because I've been looking at this problem for my entire career, my 5-year career, not great, not real long, but my time here, because as we know, the watersheds and water these are all tied together. And I mean, for example, after the fire, and I believe it was the Wallow Fire, the #1 priority for the city of Scottsdale was watershed management.
Mhm.
Their water infrastructure was destroyed. And this has rippling effects, not just from trees, loss of property, and unfortunately loss of life too. It affects all of us. So this is something that I would really like to get, not just these are the problems, what can we do? How can we actually do it in terms of policy, finances, and the approach, whether public-private or where we should try to get money to? And I'll leave it at that and let you.
People who live on the coast build seawalls, and they usually work best if you build it before the storm, right? If you build the seawall during a storm, you're not going to have much success. That's an investment in protecting that particular community. I think we need to persuade your colleagues that this is exactly like that. You're preventing and offsetting a very likely future disaster, and it's not something that we're just making up. We have thousands of projects of this kind that we've talked about today that have demonstrated to be very, very effective at, in the case of fire, offsetting extreme fire behavior. They save the extreme fire effects, and they save people's lives. So what partnership is going to make sense for that, I think, is worth discussing. There are certainly employment opportunities and benefits that are very, very significant, but I think the big picture has to do, in this case, with offsetting these extremely adverse circumstances which are going to happen. It's just a matter of when, not whether.
And additionally, another way to strengthen that argument is to think about sort of piggybacking other goals onto this. So, for example, you can do restoration after a fire and you want to restore whatever's been burned, but you can think about seeding out or planting species that are really good for livestock. So not only are you addressing the fire issue, but you're also providing another source of income for whoever's leasing that land and enhancing beef production, things like that.
And I would say that there are several examples of this kind of partnership or independent action taken by various water utilities around the country, and in some cases through partnerships. So, for example, Denver Water has invested quite a lot in protecting their watersheds on federal land. So they've paid. So it involves a rate hike for their water users, but it basically protects their watersheds because it's a huge cost to them to both treat the water and especially to dredge sediment from their reservoirs. And I know from speaking folks at Salt River Project that there's been a similar problem with reservoirs that they operate here. So mentioning Salt River Project, they would be a superb ally. They're already working with some partners on something called the Northern Arizona Forest Fund.
Forfry, they've been working.
No, this is different from Forfry. Yeah. So this again is to raise funds to do forest treatments because that's part of the water system for them. Protecting those forests is important because, as we've shown, although we didn't talk a whole lot about water quality, it affects the water quality coming down, but then there's also the sedimentation and loss of capacity in the reservoir as well. So it's an issue for them, too. Over in New Mexico, there's a Rio Grande Water Fund, and this has been a collaboration between the city of Albuquerque, which was affected by their watersheds were affected by large fires the same year as the Wallow Fire in 2011. So the city of Albuquerque, some of the non-governmental organizations like the Nature Conservancy, I believe the Army Corps of Engineers, which plays a part in water management, a greater part in water management in New Mexico, is part of that coalition. And again, the academic jargon for this is payment for ecosystem services. So if you have a healthy ecosystem and you can raise rates a tiny bit, then you can do a lot of good work to forestall millions of dollars worth of damage, having to do all the restoration afterwards. And this was exactly the approach that the city of Flagstaff
I
took
was just gonna say,
following
the bond
their
issue
big
that they
fire in
ran, very
2010.
proactive on
Yeah.
behalf
Mhm.
of the city of Flagstaff.
Yeah.
So I just was going to close with that and
Yeah.
let other people speak, but the city of Flagstaff running that, having that bond
Yeah.
issue and taking a very and got
But-
a solid community response in the vote and very positive. So
This is a kind of nasty response here, but it's also a fact of life. So we've just seen, horrible, devastating fires in California. And, there's the adage, don't let a good crisis go to waste. So that same thing could happen in Arizona. And now's the time, while it's in people's consciousness, to try to rally the troops to form a coalition to do the kind of work that you're proposing.
And not only California, we can look at Washington and Oregon.
Yeah.
Fires all over the West this year.
Yeah.
Well, every year it happens, but this year particularly devastating. Thank you so much, and thank
Thank you.
you, Senator, for this topic being brought to
Thank you so
Thank
much.
you for your question.
I have a question. It seems like these fires have jumped from being scary to being very scary with the whole trees burning down, and that is caused by both the drought and the increased temperatures? Are there any other factors that are, or is it the type of things that people are planting?
Well, yeah. So the fires in California are they're driven by one additional dynamic, which we see some places but not everywhere, and that's land use. If you look at, been some very interesting work done on modeling the physics of how fire moves through a developed area, like the areas that burned in California. And you may have noticed in some of the before and after photographs that there are whole neighborhoods where all the houses burned down and the trees were still standing. That speaks to the power of the fuel moisture that Elise alluded to. And if you think of fuel as a bundle of energy, compact energy, fire is just the release of that energy. Well, a house is a very dense concentration of fuel, actually higher density accumulation than anything you would find in nature. A wooden house is just a really concentrated energy source. And so it's the combinations of high wind, which are the result of atmospheric instability, low relative humidity, high temperatures. These are all things that go through this cyclic and progressive trend in the climate system that influence fire behavior, as well as the fuels.
Right, and I'll just add 2 or 3 other cents to that. So the California fires were preceded by a super wet winter last year, and that was through a phenomenon called an atmospheric river, the famous atmospheric river that we often hear about is the Pineapple Express. So this is a sort of a narrow band of storm activity with a large amount of moisture. Well, all of that moisture led to a lot of grass fuel growth in California that then dried out during subsequent hot and dry episodes. And they generally have a dry summer anyway in California. I was going to say something else about all of that. So part of it is the hotter drought and the drier fuels, and part of it also is a century of excluding fire from our forests, which has also led to the accumulation of fuels, as Don mentioned.
And now Representative Randy Fries
Thank you.
from Tucson.
Thank you, Senator D'Alessandro. So, thank you for the presentation today. Information and learning is part of the reason why I like participating at the Capitol. I'm just a little bit confused. I heard words like treatments and restoration, but I only heard the word prevention used once in the seawall analogy. I know where the water meets the shore. I know where to build my seawall. But do I know where the next fire is going to happen? Is there some model you use to predict the next fire and say we go in there and thin, or we go in there and seed? I mean, restoration, it's clear where you're going to do that. And you showed the Rodeo Jet-Sky fire and you showed the green areas. Was that areas where prevention was done, or was that areas where restoration was done from previous fires? Help me understand the overlap between prevention and restoration, or the distinction between the two.
Yeah, it's great. And my use of medical analogy is probably ill-advised in present company in any event. So, Smokey Bear notwithstanding, it's only partly true that only you can prevent forest fires. So what does it take to initiate a fire, right? So lightning is abundant through the Southwest. Historically, we find very high rates of fire initiation all across the state. In fact, we even using contemporary lightning density maps. Ignition is always present. So you can just stipulate that there's the potential for the ignition anytime. That leaves fuels and weather to determine whether a fire is going to happen. The fuel is the thing we can really see and that we can really modify. The weather is the game changer, if you will. And so if you're talking about prevention on a short term, let's say, for a decade, for like the next 10 years, how could we prevent fires from initiating quite so rapidly? It's the fuels that are the key leg in that fire triangle that you can actually do something about. The other word that we didn't use very much is suppression. I think Elise referred to it, but that's what you do after the fire initiates. And of course, on state lands, they still adhere to 100% suppression policy. But other federal agencies, of course, have really modified their thinking about fire. They recognize it as an essential and in some cases beneficial process that actually does a lot of the work of reducing fuels for us. But the suppression can be extremely expensive. We don't even know the bill for the California fires, but it's going to be astronomical. And just to take the analogy on federal lands, you probably know that the U.S. Forest Service spends 1/2 of their entire budget. In fact, it's now more than half of their entire budget on emergency fire suppression every year, the entire Forest Service. So that gives you some idea what the price tag is of relying on putting fires out after they've started. It's very, very difficult under extreme weather conditions. So those polygons in the Rodeo Chetasky were areas that had been thinned or prescribed burned within a decade before that fire. And it just shows that the preventive approach in ecology, as in medicine, can be very cost effective and very effective.
So how did you identify, if I may follow up, how did you identify those areas, those polygons that were thinned?
Ah,
How did you figure out we should thin here? If
Yeah.
the modifiable factor is fuels, how did you pick that area?
yeah, so those areas, it's part of agency records. They know exactly when and where they've conducted thinning and prescribed burning and what that looked like. Did they just take out a very small amount of fuels, or was it a heavy thinning? Those are all mapped out on a matter of public record. And so after the fact, the fire behavior that we saw, or the fire effects you saw, that's just the empirical observation of how that fire burned. They went in afterwards, identified all the areas that it had thinning, put those polygons on the map, and by Jove, they lined up exactly with the areas where the fire effects were less severe.
I think he wants to know why those areas
Yeah,
were chosen.
Why did
were
they
those
get
areas
chosen
chosen?
Well,
in the first place?
Yeah, okay.
Because it sounds like that works, so let's do that more.
Yeah, that's right.
How
Yes,
do we do it?
yes,
How do we
with you
set
on that.
those
Right. So generally areas that are either high fuel accumulation, they may be trying to protect some value like infrastructure or development. I will say the agencies they would love to do more of it. They would love to do more of it. We know how to do it. We know it's effective, and we know it's cost effective. So they're limited really by how much they're funded to be able to do that kind of work.
That's what I wanted to hear.
Yeah.
More funding
Okay.
for that.
Yeah,
Thank
for
you.
the preventive side. Thank you.
Thank you. One of the challenges we have at the legislature is most of our House and Senate are urban representatives in Tucson and Phoenix. Unlike Representative Otondo and I have a mix of rural, urban, and suburban. One of the complaints that have come to me from firefighters is that when we have a serious fire, it's all hands on deck, but when they would like to have access to state lands and federal lands and private lands in some cases, to more of the private to advise rather than to do the thinning, because they have to, and they have limited access and they have to fight the fires. So I'm wondering if you can respond to the challenge of having different types of land, federal, state, and personal, and access to it, because a lot of firefighters really want to get in there and do the thinning when there isn't a high fire danger.
Yeah. Well, the firefighting is generally an all lands approach, and that's because, as we saw in several recent fires, including one that in your district, fire doesn't respect those jurisdictional boundaries, and so most of the federal and state agencies have some crossover authority. But that's more, you're quite right, that's more during a live event. When you have live fire spreading, everybody coordinates just fine then. It's harder to coordinate on the prevention side because everybody has different priorities and they have different budget cycles. And I think you raise a very valid point that we could be much more effective if we could have that cross-jurisdictional collaboration when there's not an emergency happening outside our door.
Elise, since you're with the Cooperative Extension, are you working, I know you're relatively new to the University of Arizona, but are you working, I pride myself in supporting the land-grant university of the state. Do you work around the state?
Yeah, so I'm a specialist, so I'm a statewide worker, and I'm spending most of my first year sort of conducting a needs assessment and talking to all kinds of folks from agencies, NGOs, private landowners, tribes, everybody, trying to understand what their vegetation management and restoration needs are.
Thank you very much. Are there any other questions? Please don't be shy. We have Senator Peshlikai, who's also on the Natural Resources, Energy, and Water Commission. She has the largest legislative district in the country. Would you like to ask a question? I don't want to put you on the spot. I know you've had a busy day.
I don't have any questions because I just walked.
Okay. Okay.
But I want to thank you for the invite and for those of the panel that are here. Thank you, and I apologize for not.
Oh, that's okay. We know. Yeah, thank you.
Could we ask our question?
Sure. Now it's time for the panel to ask you questions. But,
So again, our motivation in asking these questions is that we're interested in working with the communities you represent, in working with you, in working with your constituents. And so I'll just read through these questions. You could pick any one you like if you're feeling up to answering these. But we'd like your take on what we presented, whether there was anything too outrageous in there or was it easy to swallow. What concerns are you hearing from your constituents about these kinds of issues? How could we best serve you and your constituents as a land-grant institution, as researchers at a land-grant institution? And is there anything that you could act on and any way that we could help with that based on what you've heard from our presentation or anything else you'd like to bring up?
And I just want to remind you, if you want to make a comment, please come to the podium that you'll be captured on the video and audio. Well, I'll break the ice, I guess. I was very, I respect science. That's why I invited you here. One of the reasons why I invited you here and with Greg's generous offer at an event earlier this year. But I think the science, the graphs that shows the change in the temperature over the last 105 or 10 years, or a little bit longer, I think it was from 1895, and also the variability in the rainfall. I mean, to see that in pictures, they say a picture is worth 1,000 words, and I believe that and the research behind it is really stuck in my mind. So I'm glad to see that because it's easy to understand. Anyone can understand that. So that's what is stuck in my mind.
Thanks.
Thank you.
Well, once again, Randy Fries from Tucson, and thank you again for the presentation. I learned quite a bit from your brief presentation. I guess one of the things that I think you could help me with my constituents is packaging that information in an understandable way. And then, how frequently do you reach out to the community and give information, sort of, not really hearings, just information meetings? What kind of community outreach do you do as a division within the University of Arizona? Try not to be so political, but you showed me some lines that were very clearly going up. And we've heard hearings where people couldn't even commit to saying, yes, that line is going up. So do you, as scientists and researchers and land-grant university employees, have a community outreach? What do you do to help the community know your science? I mean, I read journals, but not everybody else does. How do you get your science out to the average person?
Yeah, great
question.
question. Thank you.
So talking with folks obviously is really important. Cooperative extension, as a cooperative extension specialist, I speak at a lot of workshops, field days, things like that. Usually it means I'm talking to the choir, because anybody that comes to one of these workshops, regardless of what the topic is, usually they're very interested in. But I have worked in places both here and in California, that's where I was before I came here, where people weren't interested or didn't believe in climate change or whatever. And what I did instead of saying climate change or talking about it or framing the issue in that is most people, especially in this area, have seen drought. They know what it looks like and they've experienced it. So we kind of talk about it in that sense. I'm not lying or it's just sort of a slight shift in vernacular that allows us to more easily communicate about, okay, let's talk about the things you've seen. You know, you're a 60-year-old farmer. Does it seem like it's a little drier? Is it harder to raise crops? Do you have to use more water? And usually the answers are yes. And then from there, it's like, okay, well, let's look at the effects of that there's less rain, let's call it drought, things like that. You've probably heard about that sort of approach before, but that is what has worked best for me. I've walked into meetings with a bunch of I guess conservative-minded individuals and have had great discussions about drought. And I've presented the same science, and it's just a modification of some of the words I use. And I don't mean I'm dumbing it down at all, but it's just connecting with your audience. You know, we would speak to you differently than we would speak to other researchers, differently than we would speak to a fourth grade class, right? So it's just understanding your audience and the willingness of them to, you know, commit to an idea, I guess. And that's been helpful for me.
As a quick follow-up, so you are reaching out to the community to do these things, or are you waiting for the community to reach to you and ask you to come?
Usually I reach out to community, especially as a sort of newer individual. I know that there's tons of special interest groups that are tangentially interested in things like this. So it can be rancher groups, farmer groups, water conservation groups, invasive plant groups, whatever. As I was in California for 4 years, so I started getting to a point where some people knew about me and they would invite me in. But I spent a lot of time talking to non-scientists. Most of my time is spent talking to non-scientists. And so going out in the field, you know, going to a rancher meeting in the middle of nowhere where there's 4 people there, I'm there, let's talk about it. Let's, you know, and it probably wouldn't be like this. We'd all be sitting at the table just chatting, but definitely reaching out.
Great.
We thank you for this question. We talked about this very issue a lot preparing for today. In fact, we talk about this a lot all the time, you know, whether the line is going up or not. And honestly, it's a huge issue. You know, you have an elephant in the room and you want to say, oh, it's not an elephant, it's a pachyderm. And they say, oh, that's okay. You know, are you just using a different word for the same phenomenon? And it is true that, you know, certain words like drought are more palatable. But I really do think, without going beyond the bounds of what we're supposed to be talking about today, that this ability to accept scientific reality is a huge issue. And it's an issue not only among elected representatives, but among the public at large. We've seen a sea change in public attitudes towards climate change, especially among younger people. They get it, they understand that's their future. So I'm actually very optimistic that over time those understanding of the scientific reality is definitely increasing. But we still have to work with where people are today, and people like Greg and Elise are extremely skilled at trying to bridge their reality and ours.
Well, I'm grateful for your optimism. Yeah, really.
So I would, going back to your original question, I think there are the pull kind of opportunities and the push kind of opportunities. And so the pull is, as you mentioned, do people invite you to come talk? And that happens all the time, I think, probably for all 3 of us, and maybe especially for Elise and myself, since we are extension specialists. But in addition, there's the push opportunities where we might have some new finding, or there might be some new synthesis of information, and we make an effort to go into the community. Probably not often enough, though. A lot of times we hold those talks on the U of A campus, and if we went out into the community, I think we'd probably be more effective in that regard. And I will just mention one of those push opportunities that's coming up is that the fourth U.S. National Climate Assessment is in process right now. On November 3rd, that's next Friday, if everything goes right between now and then, there'll be the release of 3 reports related to the National Climate Assessment. One is the official release of the, it's called the Climate Science Special Report. So that's already been vetted by the federal government and the Office of Science and Technology Policy in the White House, and that will be released next Friday. And then 2 other reports are coming out as drafts for the public to review and comment upon. And those are the National Climate Assessment, which is more about the sorts of things that we were talking about today, about the impacts and the opportunities to reduce impacts of climate change. And the other is a special report on the carbon cycle. So that's the, about how much carbon we're putting into the atmosphere, how much we're retaining in the land and the ocean, and so on. So that report also will be a draft report for public review. So that's next Friday. And I'd be happy to speak with you about giving a talk in the community about these very issues.
And generally, when I speak at events, I say I'm the ranking member of Natural Resources, Energy, and Water in the Senate, and that's how I met Greg. And he came up to me after the meeting and said, if you'd like me to come to the Capitol. And then he graciously assembled the panel and worked out the details with my assistant, Kiana. So they are moving towards more outreach, and I'm very grateful to them for coming today.
Could I just put out maybe a follow-up question to those of you here attending? It's this last bullet. Is there anything you can act on? We realize that this is not going to be an all-or-nothing proposition. We're not going to get all the way to, even a little bit of what we talked about today. But do you see opportunities, real opportunities for bipartisan consensus on anything in this sphere that we've talked about? And if so, what might be is it around water? Is it around fire? Where might those opportunities be?
Paul, I'd just like to tell you, yesterday we were in Las Vegas for a tour of the Hoover Dam, and many of the rural legislators are on the other side of the aisle, and they're very anxious to see the tape of this meeting. It's people, when we're on the interim, they think we don't work or we don't have meetings or go any places, but it's just as for most of us, it's just as intense as it is during session. I think that fire has affected a lot of rural areas where there are people on the other side of the aisle to me. And I know that I've spoken to several of them, and they will view this tape. And I think there's a lot of common ground. I think there's a lot of common concern, so. And, okay.
I'd just say also that it seems like through this issue of fire and water, there are opportunities to link rural and urban communities, because as was described by Don and a little bit by me, it's not a case to mangle the old Las Vegas motto there, that what happens in the headwaters of the watershed stays there. In fact, it does flow down. It does affect water supplies. It does affect the sedimentation of reservoirs that provide water to urban residents. And so these kinds of arrangements whereby urban residents can pay for treatments that will improve the forest health at the headwaters will have benefits for urban areas as well. As Don put it, and I think you did too, it's an investment, but it's benefits both at the downstream end in our vital urban centers, but also in the headwaters communities that want to avoid fires, that depend to some degree on tourism and certainly on natural resources. So there's an opportunity for an interesting marriage and one that'll benefit both partners.
Definitely. Senator Peschelkai?
Thank you. Thank you. I'm Senator Jamesita Peschelkai. I represent District Number 7 here in Arizona, and it is the largest legislative district in the country. It is, I would say, 1/3, almost half of the state, and it's 7 counties and 8 tribal nations. It includes all of the Grand Canyon, San Francisco Peaks, and the largest contiguous forest in North America. So, and it goes all the way down south of Globe. So it's a large area. And last week I was in Eager for a mayor and city council members meeting, and we were sitting literally in the fire's path that was coming down from the west. So it was really, at that point, it really struck me as something that we need to educate all our communities about. You know, you look at the news this past 2 weeks, and you saw what was going on in Northern California, and you still hear about the 93 people that are still missing or perished in that fire. I think our communities feel very comfortable with fires getting that close and not evacuating, thinking, oh, well, we are part of the United States, the largest government in the world that can react quickly, and we're safe. And I think somewhere along the way, as public officials and those of us that are in the work that we do in public safety, I think we need to still put the scare into our citizens. And for example, I'll put this in a cultural way. We need to teach what is called Yi-Ya in Navajo. That's where, you know, when my parents, when I was small, you didn't ask questions. If your parents told you Yi-Ya, that was very serious. You don't touch, you don't think, you don't look, you just react. And I think we need to teach that to our citizens again on some level, that this is really something that you can't mess around with. You can't take that chance. And I don't think people realize that they're taking a chance when they're allowing that themselves to be that comfortable. So anyway, I just wanted to let you know about my experience last week. And that's all on all of us to teach that to our constituents. But just to tell you a little bit more about myself, I'm the mother of a climate activist.
Mm-hmm.
Her name is Jamie Lynn Butler. She's one of the 21 youth that is suing the federal government for the public trust. And she is the Arizona plaintiff, and she's one of 2 Native American children in that lawsuit. And my daughter, I raised her on the reservation. We don't have running water. We don't have electricity. And we're sitting out in the middle of the desert. And so the scarcity of water is very, very, impacts her life every day. And so she's a climate activist. And one of the things that I want to ask you as we move forward into the future, how well are we grooming our children? Some of them, they wake up, you know, and this is in their hearts. But I think as far as educating and always keeping professionals and experts at your level, careering children into that area. And I know you're at the university. How well do you feel that the state is supplying you with the next generation of experts? You know, that to me, my daughter, even though she's a climate activist, she's told me the other day, she says, Mom, I want to be a tattoo artist. And I thought, oh my gosh, I am failing my child somehow.
You can do both, right?
Yeah, I said, okay, you can have a real career and you can do that as a hobby. But you know, with that statement from her, I'm really wondering how we're gonna continue to be, because you're the experts. You know, you're the experts, and you're. I think I'm feeling a little bit of alarm, you know, with the hurricanes in the Caribbean, the fires in the Pacific Northwest, and climate changing. I don't know if the earthquakes have anything to do with it, but I'm just a nervous Nelly as far as being a mom, and I want to make sure that we all plan for our future generations moving forward. So I don't know if that's really a question or a series of questions or something for thought, but I want to get your response on that. Thank you.
Why don't you two parents go first?
Okay.
Have a little comment.
Yeah, we have one of those in our family too.
Tattoo artist.
Not yet. What I can tell you is that we are seeing more and more kids going from high school into college interested and knowledgeable about these issues, much more so than even just a decade ago. We have a global change ecology and management major at the university now for kids who really want to pursue this. And I would say overall, just speaking about climate awareness, that there's a much higher level of understanding among college-age kids than among many parts of the adult population. So that's a reason for optimism, and we certainly need to move forward on that much more strongly. My concern is much more what we're doing about education at the primary and secondary levels in the state, because we all know that's a major issue and a major problem for the state, and that includes being informed future citizens. And if there's any single issue, certainly in my view, any single issue that every citizen needs to understand, it would be the effects of climate on our economy and our lives and our society. So there's maybe a bit of a gap there. By the time kids get into college, I think there are good opportunities then for them to become well-educated, trained future citizens. But at the primary and secondary level, we maybe have farther to go on that score.
Yeah, I agree. I really appreciate your comments, and I think being considerate of the magnitude of an effect of instilling an understanding and an appreciation of nature and the types of things that nature provides even city kids at a young age is integral to producing and cultivating a knowledgeable, interested voting population. Most of the people I work with, if you ask them why they got into the job we're in, most of them will have some kind of answer. At least a component of their answer will be, well, I went camping when I was young, or, you know, I rode horses and I really liked it, and I started wanting to do it more and thought about it as a job. So I think focusing programs and making and ensuring that there's funding for programs and adequate education for very young kids, both in general and in sciences, and being considerate of programs that get kids outside and things like that, I think is probably one of the best things we can do to see that through.
I'm not a parent, but a little anecdote that might give you some hope, perhaps. When I was in my early 20s, I dropped out of college to be a rock and roll star. You can see how far I got. Not very far in the rock and roll category, but I was very lucky and got a second chance and went back to school. And now I'm a university professor, and it's a great privilege to be in this position as a university professor. But I guess what I'd say is, for you, I can sense that you're a very concerned parent, And that concern is probably something that's felt by your children. And I'll bet anything that they'll come out just fine. But providing also maybe on the other side of things from what Don mentioned, resources for parents to be successful as in the parenting, right? There's no manual for doing that. And, you know, maybe there are too many. Okay. At any rate, being able to provide, you know, sufficient resources so that all of our citizens can succeed will allow us to get through any of those bumps in the road, or when we get distracted and go off on some path towards something that our parents don't see as successful.
Thank you. Well, the answers are good. Thank you. I'm feeling very hopeful. And as far as the parenting manual, I just Google everything. And if
Noted.
there's a YouTube video that can go with it, I'm good. So I have another question. How I know you work with tribes as pretty well. Is there anything that you can offer to the legislators or tribes to work even better together, and like any jurisdictional issues that come up that need to be revisited as far as how well you work together? I know, for example, like you know, the forest fire doesn't stop at the reservation line when it's going. And so I need to make sure as the state senator that the services and the emergency response doesn't stop there. And with a lot of other programs and services and funding, that is the case. And this is somewhere in the area that if that happens, it could result in fatalities, and so that does concern me. And you folks are the ones that are in a place that that can help me with addressing those challenges and obstacles. Thank you.
I could mention a couple of programs at the University of Arizona that might be of help. We have something called the Native Nations Climate Adaptation Program in the Institute of the Environment at the university. And that program works with tribes in Arizona and throughout the United States to do climate education, but also to work with tribal resource managers to develop plans for anticipating current and future climate challenges. We also have the Native Nations Institute, which is part of the Udall Center for Studies in Public Policy. They, for a long time, worked on issues of governance and governance, economics, and policy. And they've added to their repertoire environmental policy, so they're increasingly working in collaboration with other programs at the university to reach out to tribes. And then finally, one of the hats that I wear at the university is as the University Director of the Southwest Climate Science Center, which is a collaboration between the USGS and the University of Arizona and a consortium of universities in the Southwest. And we have a tribal climate liaison, Holly Barton, who's a Navajo Nation member. And Holly, her paycheck is paid by by AHEC, the American Indian Higher Education Council, but she works with us in the Southwest Climate Science Center. She does a lot of outreach to students at tribal colleges and also with decision makers in the region. So those are three resources at the university where we can reach out and work with communities in the state.
Wow. Thank you.
And I guess I would just, with a little tip of the hat to the other state universities, there are some similar programs, not particularly climate-focused, at Arizona State University and also at Northern Arizona University, which has the Institute for Tribal Environmental Professionals, which is a really well-known program around the country.
Thank you.
Well, I would just want to remind you that this was the first of 3 sessions that I've scheduled with my help of my assistant, Kiana. Following that conference that you mentioned in early November, we're going to, on Tuesday, November 14th, from 2 to 4, have an ASU panel. My heart bleeds for U of A, but all 3 universities in the state have to be successful to get Arizona on the right path. And they're going to discuss environmental changes and policy impacts on agriculture, on business, and on other aspects of our lives in Arizona. And then my last session is going to be Tuesday, December 5th, from 1 to 3, and it's going to be environment and the border. And so since I represent a border district, and so does Senator Otondo, we thought that would be a good way to finish up. And again, first of all, I want to thank those of you who came to participate and ask questions. I really appreciate your attendance, and I want to remind everyone that this will be available tape. We will send you the link for it because I believe we did get very valuable information. I want to thank Greg personally for reaching out and offering to assist me in my role as the ranking member and to putting together such a great panel. I think we all learned a lot, and I think you understand our challenges that we face, and I'm so grateful for you and the University of Arizona for sending you. Thank you very much.
Thank you.
Thank you, and thanks again for the invitation.
Are the mics off yet? Okay.